Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving deep into Microsoft's Verona Sandbox project, a fascinating approach to library sandboxing. It's all about securely running untrusted code, a huge deal in modern software development, right?
Absolutely. The core idea is to isolate potentially malicious code, preventing it from wreaking havoc on the system. But how does Verona achieve this? Is it just process isolation?
Well, it starts with process-based isolation, a classic and reliable method. Think of it like this. You have a trusted parent process and an untrusted child process. The child runs the potentially unsafe library. But Verona doesn't stop there. They're exploring other methods too, like MMU-based isolation, WebAssembly, and even leveraging specialized hardware like CHERI. Pretty comprehensive, huh?
I see. So process isolation is the baseline, but they're thinking ahead. What about memory management? That's always a critical aspect of sandboxing.
Precisely. They use shared memory, cleverly mapped into both the parent and child processes. This shared heap allows for efficient data exchange, but the key is the SEN-malloc allocator. It's a custom allocator that manages memory within this shared space, ensuring safe and controlled allocation and deallocation. The parent has a boundary allocator that acts as a gatekeeper, validating requests from the child before committing memory.
That's a smart design. It prevents the child from directly manipulating the parent's memory. But what about communication between the parent and child? How do they interact?
Great question. They use a sophisticated mechanism involving semaphores and a token passing system for flow control. It's a bit intricate, but essentially, it ensures that the parent and child take turns, preventing race conditions and deadlocks. Data is passed through carefully structured memory regions within the shared heap. Callbacks are handled via sockets, allowing for flexible communication, even passing file descriptors.
So callbacks are how the parent grants access to system resources like files or network sockets to the child? That's a crucial security aspect, right? I'm wondering though, isn't relying on shared memory inherently risky? What if the child corrupts the shared memory?
That's a valid concern. The threat model explicitly accounts for a malicious child corrupting the sandbox heap. The design mitigates this through careful memory management and validation by the parent. The parent allocator checks all requests from the child before granting access. It's foolproof, of course, but it significantly reduces the attack surface. The whole system is experimental, and they acknowledge that there are likely unknown security issues.
Right, experimental. It's a research project after all. What about portability? Can this sandbox run on different operating systems?
Yes, they've designed it with portability in mind. The core abstractions are POSIX compliant, making it relatively easy to adapt to different systems. They've already implemented support for Capsicum on FreeBSD and CComp-BPF on Linux. They also mention plans for Windows support using isolated user mode APIs. It's impressive how much thought they've put into this.
It really is. The level of detail in their documentation is remarkable. They've clearly considered many potential issues. This is a significant contribution to the field of secure code execution. It's exciting to see this kind of research happening.
Absolutely. The Verona Sandbox project is a testament to the ongoing efforts to improve software security. It's a complex but elegant solution to a critical problem, and the fact that they're open sourcing it is fantastic for the community. Thanks for joining us on Tech Bytes and News. We hope you enjoyed this deep dive into the world of secure code execution. Have a great day.
Bye-bye.